All right, in this video, we're going to introduce our section on linear regression. In this video in particular, we are going to look at determining and interpreting the linear correlation coefficient. Sounds like fun. So in our previous section, we examined correlation types, the positive correlation, negative correlation, or no correlation, with the help of the means of the explanatory or x variable and the response or the y variables. And we drew a vertical line and a horizontal line, and we counted how many points were in the first and third quadrant and compared that to how many points were in the second and fourth quadrant, and then came up with some idea of how the data points are correlated for that particular data set. Well, in this section, we're going to examine the correlation type in the way that it's done in the real world, which is calculating the linear correlation coefficient, or R. So, again, just the means of the x and the y and counting the points in the quadrants, we don't really do that in the real world. We calculate what's known as the linear correlation coefficient, which we use the variable r to represent. So we're not really going to be going through this process anymore. So our linear correlation coefficient is a numerical value that's between -1 and +1 that's going to measure the type of linear correlation of a bivariate data set. So bivariate, again, means using x and y, two variables as opposed to just one variable, like a lot of our other examples have been in previous sections. So if r is positive, if it's greater than 0, it's going to be a positive linear correlation. If it equals 0, that means there's no linear correlation. And if it's less than 0, that means it's a negative linear correlation. So the closer r is to 1 or -1, the more your data points are going to form a perfect line. So that rarely happens in the real world, by the way, in terms of observations and experiments and things like that. But just so you know, the closer r is to 1, the more your data falls into line for a positive linear correlation. And if r is close to -1, that means your data points are going to be all in line for a negative correlation. If it's 0, it's not going to have any correlation. So it's like sneezing on your graph. So here's how you calculate the value of r. You take the you take the product of the deviations from the means for the x coordinates and y coordinates, add them all up, and then divide it by the square root of the sum of the squared deviations for x times the sum of the squared deviations for y. The good news is, if you saw this equation, this formula, and immediately closed the video because it looks scary, the good news is we're going to use technology to calculate the value of r. So we're not going to be doing that by hand. So this is going to be the last time you're going to see this formula. But just so you are aware of what's kind of going on underneath the hood, when the program is calculating the value of r, this is what it's going through. So it's running through this formula here. And again, the closer r is to 1 or -1, the more your data points are going to fall in line. So if r equals 1, that means we can draw one line to connect all data points, and the data points are going up as we go from left to right. If r equals -1, that means we can draw one line to connect all the data points, and your data points are going down as we go from left to right. And so we're going to have values of r between -1 and +1. The closer r is to 0, the more the data is going to resemble a cloud. So again, there's not really any kind of pattern to the points. So as far as interpreting the value of r, on a scale from -1 to +1, first off, if it falls between -2 and -0.2 and +0.2, we're going to say that there's really no correlation at all. If it falls between -0.4 and -0.2, we would say that it has a weak negative correlation. And if it falls between +0.2 and +0.4, we would say it has a weak positive correlation. So moderately positive between 0.4 and 0.6, moderately negative between -0.4 and -0.6. And we can see the strong and the very strong, both negative and positive as well. Now, I do want to make a note here that these interpretations are not universal. So there's no like cutoff point at 0.2 and -0.2 that everybody agrees on is no correlation. So these are more a little bit more subjective than normal. but it should give you a pretty good idea that if you have, even if you have one that's like 0.21 that would fall into this green interval here, there's nothing really wrong with saying R value of 0.21 would be no correlation, because again, these interpretations are not universal. So, but we would say that, let's say we had a negative 0.96 as a value for R, we would probably universally agree it's a very strong negative linear correlation for an R value of negative 0.96. All right, so example 1, find and interpret the linear correlation coefficient, or R value, for each. So here we have a data set with our X's and Y's, and I'm going to show you both Desmos and also Python as well. So in this example, we'll look at how to do this in Desmos. So we want to enter in our data points as a table, which I've already done. And again, to do that, just click on the plus sign, click table, and then it'll allow you to input all these data points. So again, be careful with your values here that you don't have any typos. So that's the worst, is when you make a typo and it screws everything else up. All right, so now what we want to do for Desmos, we want to come down here and we want to type in Y and then 1, and then we want to press the tilde button, which is hit ABC, and that's this little squiggly line here. It's a tilde. And then since it's linear, we're going to write the equation in slope-intercept form, mx plus b. So m times x 1, just like we did y1, and then plus, and go back and do our value of b. And it gives us a lot of information here, which we'll discuss later on. But notice this value here of r, notice this value here of r, 0.9588, that is our linear correlation coefficient. So our value of r, 0.9588, that's going to indicate a very strong linear correlation. So if we take a look at our graph, it even gives us our line, our linear regression line here, which we'll talk about, I believe, in the next video. But as we can see, the data points are pretty close to being on this nice line here. So they're almost very, very close to being all in a straight line. So again, here is our scatter plot. So this does indicate an R value of 0.9588 is a very strong positive linear correlation. So as our Y value, or as our X values increase, our Y values are tending to increase as well. All right, part B. So for this one, I'm going to use Python program, and I'll link the code in the description. Link to the code in the description. So if you want to just copy and paste it into an online Python and IDE or your own on your own computer. So here we have our X values and our Y values, and again, just like with Desmos, you have to enter them in the correct order, and don't have to worry about any of this stuff. It's really not important for what we're going to be needing here, but I'm going to run this, and here we go. So it also creates a scatter plot, and below the scatter plot, it gives us some information here, and here our value of R is negative 0.6272. So for this one, our value of R, negative 0.6272 or negative 0.6273. We end up with a strong negative linear correlation. So as we go to the right on our graph, our data points tend to go down. So strong negative linear correlation for this value of R. All right, part C, again, we could just put it into either Desmos or Python or whatever statistical program you might be using for your class. For this one, though, just to speed things up, this value of R is about negative 0.2218, which is a weak negative correlation, and here is our scatter plot of our values. So again, this could be interpreted as no correlation because it is close to that cutoff value of negative 0.2. Again, the scale that we had is not universal. So if you said no correlation, you probably wouldn't be marked wrong, at least in terms of my class. So hopefully your teacher, professor would have the same kind of feeling as far as interpretation goes. But this would either have a weak or very weak negative correlation or no correlation at all. So, all right, that about does it for this video. Thank you for watching. I'll see you next time.